All right. Welcome, everyone, for this talk about Apache Iceberg and Polaris, which is a new incubator project. The purpose is to introduce you what is Iceberg in the ecosystem and also Polaris in the architecture, and what the new key features that are going to be added to both Iceberg and Polaris. So I'm JB. I'm a board member of the Apache Software Foundation. I'm PMC member or committer on roughly 20 Apache projects. I also mentor and PPMC on Podlink. So with Podlink, I have a project into the incubator. And I'm contributor on Apache Iceberg and champion on Polaris. I'm also principal software engineer at Dremio. So as you can see there, and you see the mascot just before. So before going to Iceberg specifically, let's talk about lakehouse architecture. I identify, maybe you have different standpoint, but I identify 4 layers in classic lakehouse architecture. The first layer is the storage layer. It's basically a file system, object store, whatever, S3 on AWS or S3 provided by other provider. On top of that, you have a table format, so Apache Iceberg. On top, you have a query engines. So it could be Apache Spark, Apache Flink, Dremio, whatever. And between the two, I would say the glue between the query engine and the table format is the catalog. So by catalog, I mean here meta-store catalog. We will see later that it's more than that, but let's keep in mind that it's basically a meta-store catalog. So let's go with first the Apache Iceberg. So it's a table format. What Iceberg is, it's basically a specification. So specification, which is we have data files. These data files are located on the storage, and we add some metadata on top of these data files. The metadata are there to allow us first classify the data files in a way that is easier for end users, like SQL queries. So we're going to have table and views. Table is just a metadata describing this table is squaddled on different data files. But also it allows the execution engine to optimize the query. Thanks to the metadata, the query engine is doing a planification, so how it can improve the query extra. So basically, it's pretty simple in Iceberg in terms of concept. You have a data files. These data files are mostly Parquet files, so Apache Parquet, located on S3, for instance. On top of this Parquet file, we add manifest file. The manifest file contains information like partitioning, like schema, stuff like that. Anytime we're going to add new data inside a table, we're going to create what we name a new snapshot, a new commit. A commit is basically a manifest file. So the manifest file, the manifest list. The manifest list is each commit into Iceberg table is going to hand into a manifest list containing multiple manifest files. And on top of that, we gather everything in a big file used by the query engines. It's the metadata.json. So this metadata.json contains all the commits that happen on the table or a view, and then he exposes this to the query engines. So the first advantage of adding metadata on top of data file is first, it provides additional features. For instance, in Iceberg, we have a guarantee of transaction. So ACID transaction, atomicity, currency, isolation, and durability. So when the engine requests the catalog, so he says, give me the metadata for this table. And so Iceberg, through the catalog, will return the metadata.json. And thanks to that, it can create a lot of, I would say, isolation when you insert new data in the table and stuff like that. But you also have a pretty cool feature like schema evolution. So for instance, it's not a problem in Iceberg to add a new column to a table because the schema is part of the metadata. So we don't change the data files by themselves. We're just adding a new entries, a new content into the metadata. The same for the partitioning. So we're going to see what's the advantage of partitioning in Iceberg. But basically, imagine you can group multiple data files in one or multiple partitions. And this is stored also in the metadata. So imagine how a query engine can leverage this data to optimize the queries. That's one of the big things we have in Iceberg. So when I said that, when we talk about performances, what costs so much is reading a lot of files for nothing. I mean, without metadata, it means that even if I query only my first data file, maybe I will have to read all data files that exist on my storage. It was almost the Hive kind of approach that we have in the past. So now with metadata, we know the query engine can, okay, if I want to query this table, and I would like to query only the data for the last month, then I know on which data files I have to go. I don't have to read all the data files. So that's something that provides a faster and cheaper query because you optimize where the data are located. And so the partition is the same. In Iceberg, you can have multiple data files belonging to multiple partitions. So for instance, you have query that requests data for the last month, or you have a query that requests data for the last day. So it's two different kind of partition, but in Iceberg, you can have different partitioning. And when you add a partition, you can see I provided here some details. So when I create my table in Iceberg, I partition by month, but I can also add additional partition like by day, by whatever you want. Okay, it could be a transform, basically. And the thing which is pretty cool is you can have hidden partitioning. So you don't have to specify necessarily the partitioning. Iceberg can automatically expand the partitioning depending about the metadata he has. So in the past with Hive, you have to provide something like where timestamp is between this value and this value, and then with a month is greater than 1 and lower than 4. But it was, I mean, in the query by itself. Now in Iceberg, you can directly just provide the timestamp, and so he will know automatically which additional partitioning he will have to request. So that's a pretty cool feature. I will come back to you on this later because it's something that we're going to add in Polaris, additional partitioning capabilities. So some highlights about Iceberg. Who is familiar with Iceberg and the specification a little? Yeah? OK. That's not so bad. So today, the specification in Iceberg is V2. OK? We support V2 plus some additional V3 feature. But we are working on the V3 spec, and this V3 spec brings new cool features. The first thing is, now in Iceberg table, in one column, you will be able to store JSON content directly. So instead of having to work with blob and all this stuff, you just directly put JSON content in a column, and Iceberg is able to deal with that. We also have position delay. Do you know how delays file in Iceberg a little? No? OK, so I'm going to simplify a lot. What costs so much when you remove data, it's to rewrite the data files. So rewriting the data files is very costly. So instead of rewriting the data files in Iceberg, we use additional files, which is named delete file, where basically we describe all records that has been removed and we should not be considered in a query. And we have two kinds of delete files. We have a position delete, so it's pretty simple. Row number X, it's deleted. Okay, so I have a file that describes row X, row Y, extra deleted. It works fine, but sometimes it's not so good when you have to remove a bunch of data that looks the same. So in that case, we have equality delete. So equality delete is like adding a where clause in your query. So select something where this value is like this, and if the value is like this, then it considers deleted. So if you have a lot of data that looks the same, or one column which is basically the same, for instance, you want to remove all data with a month equal to 10, then you just provide equality delete with this column and this value. So what we plan to include in V3 is better positional delete file and improvement, so accelerated the query that use this positional delete and all this stuff. Variant data type is something that I mentioned in this slide, but it moved into Apache Parquet because it's more something that going to belong to Parquet. So Iceberg going to leverage it, but not Iceberg directly. It's going to be through the Parquet release. Geospatial support. So the same in some Iceberg table, you will be able to store geospatial data. So meaning that you can do some kind of analytics depending on the geolocation. Multi-column transform You remember in my previous slide there, I used partition by month timestamp. This is a transform that takes a unique argument. And in V2, it was the only option available, create transform with a single argument. Now in V3, you will be able to have transform with multiple arguments. So for instance, you can imagine to have month based on timestamp and another colon, whatever. Multi-colon transform, that's what I said. Timestamp nanosecond, that's something that we added. So up to V2, you have timestamp in second. For especially financial use cases, we added nanosecond in Iceberg. So that's the spec of a table format. In Iceberg, you have another spec, which is the REST spec. So for the catalog. This spec is used by Polaris. So that's why I mentioned there. And we have pretty cool feature that's coming. Server-side scan planning. So instead of today, each query engine is responsible of the planning and the scanning planning. Now the catalog can already provide some pre-scanning capabilities that the query engine can leverage. Another cool feature is optimize metadata.json. You remember in this slide, I said that the metadata file S0, S1, that contains S0, S0, S1, could be pretty large. Imagine if you have a CDC scenario. You have a change data capture. Each change results in one commit in Iceberg. It means a bunch of manifest lists. So it means that the metadata can be super, super large because of the manifest list, but also of the delete files. So in that case, what we can consider is the query engine doesn't care about having all the snapshot for a table. It may be one the latest, or previous snapshot, but having the list is useless for the query engine. So what the catalog can do is actually to reduce the size of the metadata.json on the fly. He said, okay, I deliver to you only the metadata.json transform, but containing only the latest snapshot, for instance. So that's something that's going to be implemented in some implementation. Endpoint discovery is another thing, like you can have some catalog that have different capabilities, but the query engine should know which capability is exposed by the catalog. So it can request a special endpoints in the REST spec that provide, okay, this is what I can do for you. So that's kind of negotiation layers we have between the client and the catalog. Authentication improvement like credential vesting and stuff like that is also something we are working on. So the reason why I mentioned the REST spec is because I said that between the query engines and basically the table format, we have a catalog. But the catalog is more than just an index. I mean, today, the first role of the catalog is really give me the metadata for this table or this view. That's the first role. But it's more than that. We can imagine to have all the features like lineage, data governance, that this user using this engine can access this column or this table, stuff like that. So there's very advanced feature. This is not part of the spec by itself, but that's something that the catalog can implement. So we can also imagine lazy snapshot loading, multi-table commits. So imagine, again, you have a CDC scenario. You have multiple events, but all events don't go in a unique table. Some event can go on table 1, and some event can go in table 2. What you want at the end is the commit on table 1 and table 2 should be sync. I mean, else you're losing some kind of coherency between the two. So that's what we name the multi-table commits. So that's something that is also supported by some catalog. Caching. Instead of reading again and again the metadata.json, why not caching it if it doesn't change? I mean, most of the queries are basically the same for a small period of time. So the specification, the REST specification, provides only the first part of the catalog capabilities. The rest depend on the implementation. And so if we take a look on the current, I mean, not the current, because now we have Polaris, but the situation about catalog, I would say 6 months ago, in Iceberg, we had a lot of different catalogs, JDBC, Hive, Hadoop, Extra. These catalogs are not all equivalent. Some support views, some doesn't support views. And second thing is there are different deployment requirements. If you want to use the Glue catalog, you have to install on Glue, of course. If you use JDBC catalog, you need a JDBC connector, RDBMS database. So it's not all equivalent. But also in Iceberg, we added Iceberg Python, Iceberg Rust. So we need a catalog can run with different kind of language, not only Java. So that's why what we did is we added the REST catalog because there are also another thing which is important. In large organization, you may have different engines, but in this organization, they want to use a unique Iceberg storage and a unique catalog. Because it's so costly to manage metadata on JDBC and Hadoop and Hive and Glue Extra. So we want something more abstract where we have the storage with the metadata from Iceberg and a single catalog. So today we have different engines. And if you take a look about these engines, you can see that most of the engine has a unique catalog linked to that. I mean, if you use, for instance, I don't know, Snowflake, you're going to use the Snowflake catalog. If you use Athena, you're going to use the Glue catalog. So there are no real interoperability between catalogs today. And it ends like this. But basically, you have a lot of different layers to manage. So that's where, basically, we bring the REST specification. And so the REST specification is part of Iceberg. The client is also part of Iceberg. And the REST catalog works with any kind of language and is also able to run with different engines. Because if the engine supports the REST spec, then it's pretty easy to switch from one catalog to another, as soon as the catalog supports the REST specification, of course. And so it's what we did at Apache. We launched the Apache Polaris project, which is a REST implementation of the specification. So the purpose of a REST of the Polaris project is first to have cross-engine read and write capabilities. So basically, multiple engines will be able to use the same Polaris instance. So imagine your query with Dremio, and then you want to use Spark, and when you want to use Glue, then these engines can still use the same catalog, which is the Polaris catalog. And also, there's a way of centralize all the authentication and authorization. So basically, your data governance. So you're going to store all the principles, the roles, etc. in Polaris. That's going to be shared across engines. And the data governance will also include governance of the engines. This engine has access to this view or not. Or this user on this engine can access to this table. Okay, so that's the kind of granularity we can have in Polaris. And also something which is pretty interesting is I said before that if you want to run JDBC, you have to use an RDBMS backend. Or if you want to use Glue catalog, you need to have Glue. In Polaris, we want to have multiple deployment support. Like you can use the storage that you want. Could be JDBC, could be a KV store, whatever. And you can deploy on different ecosystem like Kubernetes or locally or whatever. So the first thing which is super interesting is the centralized cross-engine security and access. So all engines are going to access Apache Polaris, and Apache Polaris delegate the credential to the storage, so basically to Iceberg, using credential vending. So that's something that is already implemented in Polaris, so you can test it yourself. So for instance, if your storage is S3, you can have credential vending between Polaris and S3. And so it means that all the data governance is managed by Polaris. Another thing which is super interesting is thanks to the REST API, so thanks to the REST specification, every engine can have access to basically the same layer. So Apache Flink, Apache Spark, Dremio, we are using the REST client from Iceberg, so it's completely compatible with different catalogs. And so whatever it's implemented on this engine, it's going to run out of the box with Polaris, which is a pretty cool feature compared to what we had before. And something which is interesting is, as I said, that we have different deployment options. So you can deploy Polaris locally on your machine if you want to test it. I mean, it's just a drop wizard for now application. You just run it, and you have a catalog running, and you may have multiple catalogs. I'm going to back on that later. But you can we also provide M charts to deploy on Kubernetes, EKS, GKE, whatever. So it's up to you to define the deployment layer. Could be on VMs, whatever. So this is an example of a query execution through Polaris. So basically, imagine I'm using Apache Spark as a query engine. This Apache Spark is used by a user, which is Alice. So Alice wants to access one table in Iceberg. So she's gonna execute the query on Apache Spark. This query gonna go through Apache Polaris that controls the role and credential. And so you're gonna say, okay, Polaris is gonna say, this is what I have in my metadata, because the metadata are in Polaris. So I know that Alice, using Spark, can access or not this table. If yes, then he passes the credential to Iceberg and to S3, and then he executes the query and returns the result to Alice. If not, it's managed by Polaris, and Polaris will block. So Alice won't never go to directly Iceberg. So that's the kind of thing we can implement easily in Polaris. But something which is even better is in Iceberg, in Polaris, we don't have a single catalog. I mean, most of you probably you started a catalog and you have the instance running and you are using it. But in Polaris, it's not like this. In Polaris, you start an instance, but there are no catalog yet. Then you can create a catalog. So it means that in the same Polaris instance, you can have multiple catalogs that run. So for instance, you can imagine to have one catalog for testing, one catalog for staging, one catalog for analytics, one catalog for OTLP, I don't know, whatever you want. So you create multiple catalogs, and then inside each catalog, you have the same entities as you have in Iceberg. Namespaces, tables, form, views, stuff like that. So that's something unique in terms of hierarchy, that you have catalog and namespaces, and inside namespaces, you can have over nested namespaces and also tables and views. So it means that we have two layers of permissions in Polaris. You have a global permission, which is across all catalogs in Polaris. So you're going to have a principals and principal role that are located global to all catalogs in Polaris. And then you can define a mapping between this overall role and the specific catalog role that you have inside the catalog. So you can imagine to have Alice, which is part of engineering, which is a global role across all my catalog. And this engineering role is mapped to another name inside my catalog 1. And it could be another name in catalog 2, because I may have different model. So that's something that you can do in Polaris. So this is an example. So I'm JB. I'm I have two roles, engineer and data team. This is across all catalogs. And then this, I have two catalogs, Clickstream and 3P apps. And so for this engineering role, which is a global role, I map to my catalog admin and catalog reader, for instance. So this is the kind of granularity and permission model you can implement in Polaris, which is pretty flexible. So some ideas and roadmap we have about Polaris. The first thing is, so today you have two kinds of catalogs that exist in Polaris. The internal catalog, basically the metadata are stored by Polaris itself, but we also support external catalogs. So imagine you have an existing Glue catalog, or you have an existing, I don't know, JDBC catalog. You don't want to move manually all the metadata from this catalog to Polaris. What you can do is, in Polaris, you're going to use this external catalog. It's read-only for now, so you cannot add new metadata in these external catalogs, but it can be used by a unique instance of Polaris. What we plan to do, I don't know when, to be honest, we started to discuss with it in the community, but it's what we name the federated catalogs. So it means that all catalogs that you have will appear at one in Polaris. And in that case, we're going to support read and write of the metadata. Some other ideas that we have is, I said that we have role-based access control, so per table or per view, but why not having row-based access control or column-based access control? Like my user, Alice, can access to this table, but only this column of this table, not the other one. Okay, so that's the kind of feature we can add. Catalog level versioning is something that we are discussing. Multi-table transaction, we started already. For now, it's only in memory, going to be pretty soon stored on the storage. And I would like to mention also something, it's all performances optimization by Polaris. I talk about the metadata.json optimization. We may see a lot of other things that could be optimized by the catalog. So the engine will not know that it is an optimization from Polaris because they just receive the metadata.json. But it's not the real one. It's the one optimized by the catalog. So that other things we are working on. Thanks for your attention. Any question? No question? Yeah? Hold on. Yeah?
So would you know whether other catalog implementations would like to follow the REST specification that you just explained?
Yeah. So the question is, will the other implementation, catalog implementation, will follow the same specification? I'm going to be pretty concrete. I'm going to take an example from Dremio. We have a catalog, which is named Nessie. Maybe you heard about Nessie as a catalog. For good reasons, we deviate a little from the REST specification because we wanted to implement stuff. What we want to do is, we are contributing on Polaris, and we are planning to contribute Nessie features in Polaris. And the purpose is to be back on something which is REST compliant, REST specification compliant. So my point on this, and I already shared this vision on the main list, is Polaris has to implement the REST specification from Iceberg, not deviate from that. And it's up to the Polaris community to work with the Iceberg community to improve the REST specification if needed. The good news is we have a lot of Iceberg PMC member part of Polaris. So it's going to simplify the communication between the two communities. Other question? Anyway, this afternoon I'm going to be on the Dremio booth, so if you have any question, you can come and we can chat about Apache and Iceberg. Thank you.